Class number 3, daily summary. In this lesson, we see 4 fairness criteria. These criteria look at who won an already completed election and decide if the outcome was unfair. Number 1, the material in this section is tough, so be patient with yourself and expect to struggle with the new vocabulary and ideas. We start by making sure we have a clear understanding of if-then statements. 2, suppose I want to stick to an exercise regimen and I plan to follow this rule. If the weather's okay, then I will go for a run in the morning. Number 3, either the weather's okay or it's not. Either I run or I don't. Let's look at each of the 4 possibilities below and decide whether or not we broke our rule in each scenario. Part A, the weather is okay, I go for a run. All right, so we have to decide whether or not we fulfilled the promise that we made to ourselves. I'll highlight our promise right up here. If the weather's okay, then I will go for a run in the morning. So part A, the weather is okay, I go for a run. It seems like that's a true statement, right? I fulfilled my promise. I am being true to myself. Part B, the weather is okay, I don't go for a run. Well, okay, look at the yellow highlighted promise. If the weather's okay, then I'm going for a run. But in part B, the weather is okay and I don't go for a run. In this case, I have lied to myself. This is a false statement. Right? That's the only way to make it so that we break our rule. Part C, the weather is not okay and I go for a run. The weather is not okay, I go for a run. A lot of folks think that this is another instance where we lie to ourselves, but actually we have not lied to ourselves. The promise highlighted in yellow says, if the weather's okay, then I will go for a run. But it doesn't make any guarantees about what I'm going to do if the weather is not okay. And so I did not lie, I did not break my promise. The weather was crummy, I went for a run anyway. It's sort of neither here nor there. But in any event, I didn't lie. So that's a true statement there. Okay, and then finally, part D, the weather is not okay, I don't go for a run. Again, looking at the yellow promise, if the weather is okay, then I promise I'm going to run. Part D, the weather was not okay, I didn't go for a run. Again, neither here nor there. I did not make any promises for what I'm going to do or not do if the weather is not okay. And so the only way that I lied is here in part B, the scenario where the weather was okay, but I don't go for a run. And so in that case, the weather was okay. Yes, it was. But I went for a run. No, I did not. Number 4, to summarize, the only way an if-then statement is false is if the if part is true, that was the weather being okay, and the then part is false. That was I go for a run. Now let's get back to our analysis of elections. Number 5, for a completed election to be considered fair, it must meet certain criteria. That is to say, the outcome must meet certain criteria. The first and most basic expectation is the following: majority criterion. This is the first of 4 different criteria that we're going to see today. If candidate X has a majority of the first place votes, then candidate X should be the winner of the election. Remember again, majority means more than half. Number 6, and hopefully that seems completely reasonable, right? If somebody gets more than half of the first place votes, that means they are the preferred candidate for more than half of the voters. They should win the election regardless of how we happen to calculate the vote. And remember, we've got 4 different ways we can calculate the vote: plurality, Borda, plurality with elimination, and the method of pairwise comparisons. Okay, number 6, let's analyze the majority criterion by considering the following preference schedule. Part A, does any candidate have a majority of first place votes? Okay, let's see. In this particular election, we had 4 plus 2 plus 1. That's 7 voters. So a majority would be more than half. So in this case, we would need 4 or more. Does any candidate have a majority of first place votes? Yeah. A has exactly 4 votes, which is how many we would need for a majority. Part B says calculate the winner using the Borda method. Okay, so we've got a little bit of work to do here. Remember, Borda awards 1 point for last place, 2 points for second to last place, and then so on. So in this election, I did not do that, right? Yes, I did. In this election, we had 4 candidates, so the first place vote is worth 4 points. Okay, so let's go in the bottom row. This guy right here, D, that's 1 point for each of 4 voters, so that's 4 points for D. This one here is 1 point for each of 2 voters, so that's 2 points there, 1 point for A there. Let's focus here. B in this case gets 2 points for being in 3rd place, but there are 4 voters giving B 2 points each. So 4 times 2, that's 8 points right there. So remember, the idea here is that we're just going to multiply everything in this row by 2 points. So that 2 voters times 2 points, that's 4 points. 1 voter times 2 points is 2. Right here, 3 points each for 12 voters. 3 points each for 4 voters. 4 times 3 is 12. And here, clearly, we're going to be multiplying everything by 3 points. So 2 times 3 is 6. 1 times 3 is 3. And then finally, 4 points each for any first place vote. So 4 points, 4 voters. That's 4 times 4 is 16. 4 times this 2 is 8. And 4 times that 1 is 1. And so now we're just going to tally all of the votes, all of the points for each of these candidates. So for A, I see 16 points in the first column, 2 points in the next column, and then 1 point in the last column. So that's a total of 19 points for A. Moving on to B, first column got 8, second column 6, last column 2. That's 16 there. C, first column 12, next column 8, last column 1. That doesn't make sense. Let's try this again. Should have been a 4 right there. Plus 4. Okay, so altogether there, that's 24. And then finally D. First column has 4 points, 4 points in the second column, 3 points in the last column. So altogether 8 and 3, that's 11 points. We'll do our quick check here. Remember, we got 7 voters here. And in this case, 10 points for each candidate. Every voter is giving 10 points out. 1 point plus 2 points plus 3 points plus 4 points. So 7 voters giving 10 points away is 70 points altogether. And so as a check here, we can see if 19 plus 16 plus 24 plus 11, we're really hoping we get the 70 that we got there. Okay, 9 and 6, that's 15, and 4 is 19, and 1 is 20, so that's a 0 carry to 2. 2 and 1 is 3, and 1 is 4, and 2 is 6, and 1 is 7. That makes us happy. If I had made that mistake, or if I had not caught this mistake right here, remember I had accidentally put a 1 right there in that spot. And so that would have brought this number down to 21, and that would have brought this down to 67, and I would say, oh, that's not great. And I would need to go back and try to find my error. Okay, so I think we're good. All right, so we're just looking for the winner using the Borda method. So whoever got the most number of points using Borda, let's see, I think that's candidate C, right? C wins with 24 points, more than anybody else. Okay, so just going back through our answers here, part A, did any candidate have a majority of first place votes? Yes, A had a majority, 4 first place votes. But when we found the winner using the Borda method, we didn't get A winning, we got C winning. C won using the Borda method. And it's small consolation to A that they came in second place with the Borda method. They didn't win. So here's our summary. A had a majority of first place votes. That's the if part of the majority criterion, but A didn't win using the Borda method, which is the then part of the majority criterion. Remember again, the majority criterion said, if one candidate has a majority of first place votes, they should win, regardless of how you happen to count the votes. According to the majority criterion, this isn't fair. The outcome of this particular election using the Borda method is not fair. A should have won because they had a majority of first place votes, but A didn't win when we counted using Borda. We say that in this election, not in every election, but in this election, the Borda method violates the majority criterion. The Borda method violates the majority criterion. Number 8, another criterion for fairness is the Condorcet criterion. If candidate X is preferred by the voters over each of the other candidates in a head-to-head comparison, then candidate X, the Condorcet candidate, should be the winner of the election. So one more time, if one candidate beats every other candidate head-to-head, then that particular candidate who beat everyone else should be the winner of the election, regardless of how you happen to count the votes. So here's a preference schedule. Looks like we've got 5 different candidates in this election: R, H, F, O, and S. So who wins according to the plurality method? So plurality method just means first place votes only. So looking in the first column, we can see R gets 49 first place votes. Second column, that's H, getting 48 first place votes. And then finally F, getting 3 first place votes. I guess just to be complete, I will also list S and O. They each got exactly 0 first place votes. So who's the winner according to the plurality method? R is the winner with the most number of first place votes. In this case, how many voters do we have altogether? It looks like 100 in total. And so a majority would be more than half, which would mean more than 50, which would be 51 or better. So R didn't get a majority of first place votes, but that's okay. The plurality method just gives the election to whoever has the most first place votes, even if they don't have a majority. Part B, is there a candidate who beats every other candidate in a head-to-head comparison? Okay, so we actually don't need to do every single head-to-head comparison. We're just looking to see if there's a single candidate who beat every other candidate head-to-head. This is us looking at the if part. If candidate X is preferred over each of the other candidates in a head-to-head comparison. So we're just looking to see if we can find somebody where the if part is true. Okay, so it seems like just looking at the plurality count we did, the only possible candidates who could beat everybody head-to-head would be R or H. Nobody else has any chance of winning head-to-head against everybody. So let's just look at R versus everybody. For example, R versus H. Okay, so in the first, I'm going to highlight all the R's in green here and the H's in yellow. Okay, so R versus H. So who gets those 49 votes in the first column? Well, that's R, preferred over H. Who gets the 48 votes in the second column? Well, that's H. Who gets the 3 votes in the last column? Well, it's not F, because F is not part of this head-to-head. Who do these 3 people prefer between H and R? They prefer H. They have H up above. So H actually gets not just these 48, but also these 3. So H got 51 right there. And again, as our quick check, we add up those numbers, 49 plus 51, and we get 100, which makes sense. There were 100 people. Every voice has to get heard. So in this case, H was the head-to-head winner against R, which means that there's no chance that R beats every other candidate head-to-head because R just lost to H. So let's continue on H versus anybody else. So let's try H versus, what else can we do? H versus F, H versus S, and H versus O. Okay, I'm going to leave H highlighted in yellow. And let's move on to H versus F. In the first column, H or F, who do they prefer? They prefer H. In the next column, H or F, who do they prefer? They prefer H. And in the last column, H or F, who do they prefer? Oh, actually, they prefer F. Okay, so that means that the first 2 columns go to H, and the last column goes to F. So that gives F 3, and H gets 49 plus 48. That's 97. Well, good. Okay, so H won that one pretty handily. H versus S. Okay, H versus S, first column. Who gets those? Okay, that's clearly H. H versus S. Oh, that's H again. H versus S. That's H again. So actually, this is a shutout. H gets 49 plus 48 plus 3. That's 100. S gets 0. H versus O. Let's see. H beats O. H beats O. H beats O. That's another shutout. 100 to nothing. So that means that H won that head-to-head and H won that head-to-head. So in this case, did we have a candidate who beat every other candidate in a head-to-head comparison? The answer is yes. H did. And just again, vocabulary, H is called the Condorcet candidate because they beat every other candidate head-to-head. In many elections, there will be no Condorcet candidate, but in this case, there was one. So again, the Condorcet criterion said that if there's somebody who beats everybody head-to-head, H in this case, then that candidate, H, should be the winner of the election regardless of how you count the votes. But again, in part A, when we did the plurality method, did H win? No, H did not win. R was the winner in a squeaker, but R was the winner using the plurality method. So that's not fair, right? H got shortchanged here. H was preferred in a head-to-head battle against every other candidate. The people have spoken. And yet when we use the plurality method, which only looks at first place votes and ignores everything else about people's preferences, H did not win. So part C, in this election, and we're going to fill in the blank, some method violates or does not violate the blank criterion. So in this case, we counted the votes using plurality, and we had something that was not fair. The plurality method did violate. B, and then which criterion were we talking about? This was the Condorcet criterion. Number 10. Our third fairness criterion is hard to pronounce. It's the monotonicity criterion. If candidate X is the winner of an election, and in a re-election, the only changes in the ballots are changes involving some voters ranking X higher on their ballot and not changing the order of any other candidates, then candidate X should still be the winner of the election. Okay, there's a lot going on in this criterion. Let's take a look at a concrete example in 11 and see if we can make some sense of the monotonicity criterion. 3 cities, Athens, Barcelona, and Calgary, we'll abbreviate ABC, are competing to host the Summer Olympic Games. The final choice is made by a vote of the IOC, the International Olympic Committee, and the winner is chosen using plurality with elimination. 2 days before the actual election is to be held, an unofficial poll of the members of the IOC is conducted just to see how things stand. The results are in the table below. Using plurality with elimination, who is expected to win the election? Okay, let's try that first. Remember, we're looking for, we got to figure out how much is a majority, so we do our sum, 7, 8 plus 10 plus 4, I think that's 29. And then plurality with elimination involves first counting the plurality votes only. First place votes only. Okay, so looking at A, first place votes for A, I see 7 there and I see 4 there, that's 11 total. First place votes for B, only this column, that's 8 for B. And then first place votes for C, that's only this column, that's 10. Okay, realize that we forgot to come over here and finish this calculation. So we need to know how many is a majority. So the 29 voters, a majority would be more than half, more than 14.5. That's 15 or better. So plurality with elimination doesn't say eliminate the last place candidate. First it says, does somebody have a majority of the votes? And if so, you stop calculating, they just won the election. So does anybody have a majority? Does anybody have 15 or more? The answer is no. And so in this case, we eliminate whoever has the least number of first place votes, that is candidate B. And so we eliminate B, which means crossing off all of the B's, and then recalculating first place votes. Okay, I'm going to highlight here first place votes. A there, but now first place votes for C, and then the rest of that first row. Okay, so A and C. Okay, first place votes. A has 7 here and 4 here. That's still 11. C, okay, let's see. C had 10 before, but they just picked up 8, even though they weren't this column's top choice. B is no longer an option, and so they think C is now their best candidate. So again, C got 10 plus another 8, that's 18. So does somebody have a majority? Remember, a majority was 15 or better. Yes, C has a majority, and so this election just ended. C wins. Okay, but that was the unofficial election. B here says the results of the unofficial poll are supposed to be secret, but the results leaked out. The delegates in the 4th column decide they want to be able to say that they helped elect the winner. Well, we know that the winner is going to be C, right? We just calculated that. So they decide to put Calgary first and move Athens to second. Let's create a new preference schedule and determine the winner of the election using plurality with elimination. Okay, so the only changes here are in the last column, the fourth column. So we're just going to copy the other columns as they are. So 7 people thought A and then B and then C. And then 8 people thought BCA was the best order. And then 10 people thought CAB. But now these last 4 people decide they want to help Calgary win. Calgary's going to win anyway, so they can say that they helped. So they're going to put Calgary first and move Athens to second. It's just swapping those two and then copying B down in the last spot. So all these last people did was move Calgary higher, and they copied everybody else, right? Just moved Calgary up, and anybody else, like A in this case, just came down a little bit. So really, now that we see the last 2 columns are the same, probably we should smush them together. And so maybe we just call these 2 columns right here 14 people. I probably wouldn't even have them in separate columns. So why don't we just erase and say there's now 14 people. There's preference. It's C and then A and then B. Okay, part C, to summarize. Oh wait, we didn't finish part B. Create a new preference schedule and determine the winner using plurality with elimination. Okay, let's give this a shot. So plurality with elimination, first place votes only. A, B, and C. Okay, they're just there in order, 7 and then 8 and then 14 first place votes. Remember, a majority in this case was 15. Does anybody have a majority in this case? The answer is no. No majority, so we eliminate A. And so let's get rid of the A's. And then I'll highlight first place votes now. First place votes, okay, it's not A anymore, it's B there, and then the rest of the first row. And so when we do our second round here, M and 8, I don't know what's going on there. Let's try that again. Okay, so now first place votes for B and C. Okay, C still has the same 14 first place votes they had before, but B just picked up some more votes. These 8 people still think B is the best. These 7 people, they preferred A, but A is out of it now, so we go to B. And so we got 7 plus 8, that's 15. Again, our quick check, add those 15 and 14, that's 19. Sorry, that's 29, which is the right number. And so who just won? So in this case, B wins by having a majority. Majority was 15. Okay, so to summarize, this is part C. Calgary was the winner of the unofficial vote. We calculated that on the last page. Then a revote happened, and everyone kept their votes except exactly the same, except some voters who moved Calgary higher on their ballots. Remember, that was the last 4 people. They said, we want to be part of this. We want Calgary to win even more. And so they put Calgary higher, stronger. Surprisingly, Calgary did not win the revote. B won the revote. And that doesn't seem fair because Calgary should have been the winner, but because the results leaked out and some people voted Calgary even higher, Calgary didn't win. Very, very strange. Thus, in this election, the blank method. Okay, so what method did we use to calculate the winner here? This was plurality with elimination. Does it violate or does it not violate? We saw a clear violation here, something that was not fair to Calgary. Violate the blank criterion. So which criterion? This one is the monotonicity. Okay, number 12. Our final fairness criterion involves a candidate dropping out of an election. It's known by a few different names. The independence of irrelevant alternatives criterion, also known as IIA. It's not 2A, that's II for independence and irrelevant. It's also called the dropout criterion for reasons which will become clear. If candidate X is the winner of an election and in a recount one of the non-winning candidates withdraws or is disqualified, then X should still be the winner of the election. To be clear, we're only getting the people to go vote once. It's only one election here. And we just count the ballots and somebody wins. But then we do a recount where one of the non-winning candidates decided to drop out. But then we just count the same exact ballots once we've eliminated this person who withdrew. Then the original winner of the election should still be the winner of the election, right? If one of the losing candidates goes away, The outcome should not be changed. 13, it's time to elect a mayor in Greenfield. There's a very small turnout at the polls as indicated by this preference schedule. Oh dear, there's only 3 and 2 and 2. That's 7 people showed up. Let's find the winner using the plurality method. So first place votes only. A gets 3, B gets 2 in the last column, C gets 2. So that means that A is the winner of using the plurality method. After the votes were all cast, but before the votes had been counted, apparently the people doing the counts are very slow, a scandal involving candidate B comes to light. Candidate B decides to immediately withdraw from the race. Since the votes have already been cast, the election is officially completed. It wouldn't be fair to the candidates or to the voters to ask people to re-vote. Now, in this case, having B disappear should not have any impact, right? A won the election fair and square. Whether or not B is in there should hardly make any difference. Okay. Once B has been crossed off of all the ballots, who is the winner of the election using the plurality method? Okay, so B is no longer fair game, but people have already voted, so we're just going to take their preferences as stated and count plurality votes. First place votes, but now B is not there, so those last 2 votes from the last column have to go to C. Okay, A equals C equals. Okay, A still has 3, but C only had 2 from the middle column, but they just got 2 more from the last column. C has 4. So who is the winner now? C wins, which seems patently unfair to candidate A. Candidate A won the election fair and square. Candidate B dropped out. Who cares? It shouldn't make any difference, and yet it changed the outcome of the election. By having B disappear, B was an irrelevant alternative. B did not win originally, but this irrelevant alternative dropping out somehow completely changed the outcome of the election. C ended up winning instead of A. Okay, let's fill in our sentence. In this election, the blank method. All right, how did we count the votes here? This was the plurality method. Violates or does not violate. This is a clear violation. It's not fair that A didn't win on the recount. The blank criterion, this is the independence of irrelevant alternatives criterion, also known as the dropout criterion. B was the dropout candidate. Okay, and before jumping to the activities, we'll have a quick look at the summary of violations of the fairness criteria on page 9 of this packet. So let's go to page 9. Okay, so here on page 9, the first part of this page is the explanation of the different methods, the ways to count the votes. So we did plurality and Borda, plurality with elimination, and the method of pairwise comparisons. So 4 ways to find the winner of an election. Then the new stuff for today are the fairness criteria, 4 ways to look at the outcome of an election and decide whether or not that outcome was fair. So majority, Condorcet, monotonicity, and independence of irrelevant alternatives. And then the thing I just want to focus on here is this last part, which will be kind of new, how to determine that there is a violation of each of our fairness criteria. So remember, the only way an if-then statement is false is if the if part is true and the then part is false. So the majority criterion, remember, said if a candidate had a majority of first place votes, they should win. So the way to find a violation in this case is to find a candidate who has a majority of first place votes but doesn't win the election. If you can find a candidate with a majority of first place votes who didn't win the election, that's a violation of the majority criterion. And to be explicit, there are lots of ways where the majority criterion would not be violated. For example, suppose that no candidate had a majority of first place votes. Well, then the majority criterion does not even apply. So there's no possible way the majority criterion could be violated in a particular election where no candidate has a majority of first place votes. The majority criterion only makes a promise if somebody has a majority of first place votes, then I promise they should win. So if nobody gets that majority, the majority criterion cannot possibly be violated in that particular election. Another way to not violate the majority criterion is if if there is a candidate that has a majority of first place votes and they happen to win the election, then the majority criterion would say, hey, that's fair. There's no violation, okay? So the only way you can violate the majority criterion is if you can find a candidate who has a majority of first place votes, but that candidate doesn't win the election. Okay, part B, how to violate the Condorcet criterion. You're going to look for a candidate who beats every other candidate in a head-to-head comparison, but doesn't win the election. Part C, to violate monotonicity, you're looking for a candidate who wins the election, but then doesn't win in a re-election with exactly the same votes as in the original election, except for some voters who ranked the candidate higher, that winning candidate higher, like the Calgary example for the Olympics. And then finally, the violation for the independence of irrelevant alternatives criterion. You want to find a candidate who wins the election, but then doesn't win when the votes are counted again after some other candidate dropped out, after some losing candidate dropped out. Okay, so as we mentioned at the top, this is challenging material, lots of new vocabulary, so be patient with yourself as you work through the activities and the homework.